Today we're going to talk about optimization problems. To optimize something, you're looking for the optimal value. So in a business sense, you were looking for the best outcome. So if you were looking at something like cost, you want to have the minimum cost possible, the least amount of money possible spent. And when you're looking at something like profit, you're looking for the maximum possible profit to earn the most amount of money. So when you're finding optimizations, this is just an application of finding your absolute maximums and your absolute minimums. Except here, unlike in previous lessons, we're not going to have an interval, right? It's just going to be in general, what is the absolute maximum, what is the absolute minimum, depending on what your optimal value would be. Regardless if you're maximizing or minimizing, the process is still the same. Your method of approach, the first thing you want to do is find the equation that you are trying to optimize. Are you trying to find the maximum profit? Then make sure you have your profit function. Are you trying to find the minimum cost? Then make sure you have your cost function. Once you have the equation or the function that you're trying to optimize, take the derivative, set the derivative equal to 0 and solve. That's going to give you your critical value. And then use that value to answer whatever the question is. So let's look at this first example here. The revenue in dollars for a company is given by 3,000x plus 45x squared minus x cubed, where x is the number of units sold. What level of sales will maximize the revenue, and what is the maximum revenue? So I'm looking for the level of sales. In other words, how many units do I need to sell to maximize the revenue? And when I sell that many, what is the maximum revenue I would get? Step one, as you recall right up here, is to find the equation. Well, I'm trying to maximize the revenue. Revenue is given for me, so I don't have to do anything for step one. Step two, take the derivative. That's going to give me 3,000 plus 90x minus 3x squared. Step three is to take that derivative and set it equal to 0. So I put it in descending order, negative 3x squared plus 90x plus 3,000 equals 0. I pulled out a negative 3, and then I factored the x squared minus 30x minus 1,000 into x minus 50 times x plus 20. Set each factor equal to 0, and I get x equals 50 and x equals negative 20. But x is the number of units sold. You can't sell negative units, so this answer doesn't help us. This answer doesn't count, so we ignore it. And so x is 50. Now again, x is the number of units sold. So what level of sales will maximize the revenue? In other words, how many units do I need to sell to get my maximum revenue? X is the number of units, so that's 50. What is the maximum revenue? Well, here's the revenue for X number of units, and I know that I need 50, so I'll plug 50 in there, like I did down here, and you can see that we need to sell 50 units to maximize the revenue, and the maximum revenue will be $137,500. Let's look at another example. A wholesaler notices their demand can be modeled by P equals negative 0.2x plus 100. What price per unit will yield a maximum total revenue? So this demand function here, this little p here is price, but I am trying to maximize a revenue. I don't have my revenue equation here, but I do know that revenue is equal to price times quantity, and this demand function, little p here, gives me price. So when I substitute in that negative 0.2x plus 100 for price, in quantity x, distribute the x, now I have my revenue function, negative 0.2x squared plus 100x. Step two, take the derivative. Step three, set the derivative equal to 0 and solve, and that gives me x equals 250. But remember, x is the number of units. So I know that we need to sell 250 units to get the maximum revenue. But that's not what the question asked. The question said, what price per unit will yield a maximum revenue? I know how many I need, so now I need to use this equation right here to find the price I should charge. So into the price function here, I'm going to plug in 250 units, and I end up with 50. So to maximize the revenue, I know I need to sell 250 units, but more importantly, to answer the question, I need to sell them for $50 each. Make sure you're answering the question. Let's look at this example. A commodity has a demand function, which is 100 minus 0.5x squared. We just talked about how a demand function, this little p, is price. And a total cost function of 40x plus 37.5. How many units need to be sold to maximize the profit? What price will give us that maximum profit? And what is that maximum profit? So what am I trying to do? The idea here is to maximize the profit. This is not profit, this is price. So I'm going to need to find the profit function. Well, profit is revenue minus cost, but I don't have revenue here. I only have price and cost. But I know that revenue is price times quantity. I just did that. I've got my price right here. So when I distribute the x, I get that my revenue function is 100x minus 0.5x cubed. So now I can find my profit by taking revenue, which I just found right here, minus cost, which was given to me. And when I do that, don't forget to distribute this negative. We are subtracting off the entire cost function, so we need to subtract off each of the pieces. So it's going to give me 100x minus 0.5x squared minus 40x minus 37.5. Combine my like terms, and I get a profit function of negative 0.5x cubed plus 60x minus 37.5. Step 2, take the derivative. I get negative 1.5x squared plus 60. Set the derivative equal to 0. And when you do, you get x squared equals 40. So when you take a square root to solve, you have to take plus or minus, which gives you two answers, the positive and the negative. But we know we can't produce and sell negative units, so we're just going to concentrate on this positive one right here. X equals 6.32. So X is the number of units. How many units do we have to sell? 6.32. What price? We'll plug 6.32 into the price equation. And what is the maximum possible profit? We'll substitute in 6.32 into my original profit function. So to get the price, plugging in 6.32, I get about $80.03. To get the maximum profit, I plug 6.32 into the big P profit function, and I get $215.48. Now, the average cost function can be found by C with a bar above it, which is your total cost function divided by the number of units. For example, if you went out to 5 different stores and you bought 10 different shirts and you spent $700, then you would say, okay, I'm spending an average of $70 per shirt. That does not mean that each shirt costs $70. That was the average cost. You take your total cost divided by how many you made or how many you bought or whatever your situation is, and that'll give you the average. So we're talking about the average cost function, which is, again, the total cost function divided by the number of units. An industry with a monopoly on a product has an average weekly cost in dollars given by the average cost function, that's C with a bar, 10,000 over X plus 60 plus 0.04X, where X is the number of units produced. Producing how many units will minimize the average cost, and what is that average cost? All right, so first things first, I'm going to rewrite my average cost function so that it's easier to take the derivative of by bringing this x up and giving it a negative exponent. So my average cost function is 10,000 x to the negative 1 plus 60 plus 0.04x. Take the derivative, bring the negative 1 down, take 1 away, so I get negative 10,000 x to the negative 2. The derivative of 60 is 0, and then the derivative of 0.04x is 0.04. Step 3, set that derivative equal to 0 and solve for x. So I will subtract that 0.04, multiply both sides by x squared to get that x squared out of the denominator, divide both sides by negative 0.04, and I get x squared equals 250,000. To solve for x, I have to take plus or minus the square root, which gives me two answers, positive 500 and negative 500. But we know we can't produce a negative amount of units, so the number of units we're looking for is 500. What did the question say? Producing how many units will minimize the average cost, and what is that average cost? I know it's going to be 500 units. I'll plug 500 into the original average cost function to get 100, and I can see that producing 500 units will minimize the average cost, and the minimum average cost will be $100 per unit. Let's do another one similar. A company manufactures expensive jerseys to sell to college bookstores in runs of up to 500. It costs in dollars for a run of X jerseys, 2,000 plus 10X plus 0.2X squared. So how many jerseys should the company produce per run to minimize the average cost? So this is the cost function, but I don't want to minimize the cost function. I want to minimize the average cost. So step one, find the equation you're trying to optimize. In this case, minimize, which is average cost. Your average cost function is your total cost function divided by X. So here's my total cost function divided by X. Now I know that I'm going to have to take the derivative, and I don't want to take the derivative of this because this would use the quotient rule. But if I'm dividing all of this by X, then I can divide each of those pieces by X. 2,000 divided by X, the 10X divided by X, and the 0.2X squared divided by X to get an average cost function of 2,000 over X plus 10 plus 0.2X. Like I did before, I'm going to bring this X up and give it a negative exponent to make taking the derivative a little bit easier. Step 2, take the derivative, as I did here, negative 2,000 X to the negative 2 plus 0.2. Step 3, I brought the X squared back down to set it equal to 0. Negative 2,000 over X squared plus 0.2 equals 0. Subtract the 0.2. Multiply both sides by X squared. Divide by negative 0.2, and I get X squared equals 10,000, or that X is plus or minus the square root of 10,000, which gives me two answers, 100 and negative 100. We know we can't take the negative amount of jerseys, so we're going to ignore that. And we know that the company should produce 100 jerseys per run in order to minimize the average cost. Let's do one more example. A time study showed that on average, the productivity of a worker after T hours on the job can be modeled by P equals 15T plus 6T squared minus T cubed, where T is between 0 and 8. And P is the number of units produced per hour. So they're measuring productivity by how many units you can produce every hour. Why do we have this stipulation here? 0 is less than or equal to T is less than or equal to 8. Well, the least amount of hours you can work is 0. And at this particular company, the most amount of hours you can work is 8. So this is the number of hours that you can work per day, between 0 and 8 hours. After how many hours will this productivity be maximized, and what is the maximum productivity? Step 1, what's the function we're trying to maximize? Productivity, it was given to us. Great. Step 2, take the derivative, 15 plus 12t minus 3t squared. Step 3, set the derivative equal to 0 and factor. I pulled out a negative 3, and then I factored into t minus 5 and t plus 1. Set each of those factors equal to 0, and we get t equals 5 and t equals negative 1. But remember, t is the number of hours on the job. You can work 5 hours, but you can't work negative 1 hours. You can't have negative time, so we have to ignore that. So how many hours will productivity be maximized? 5. What is the maximum productivity? We'll have to plug 5 back into that original function there to get 100. So after 5 hours, productivity will be maximized, and the maximum productivity will be 100 units per hour. That's it for this time, and I will see you in the next video.